All right. So today what we're talking about is we're going to be talking about the quadratic formula. Okay. This is another method to solve parabolas or to solve quadratic equations. Okay. What does that mean? It means it gives you the roots or zeros of the parabola. Okay. Wherever it crosses the x-axis. This method is one, it's quick. It's all algebra. It's all algebraic, so we actually solve it using calculator. You can graph most of these quadratic equations, but you guys know graphing takes time. Okay, and it leaves you in a situation where sometimes you have to estimate, which is never good in an approximation. Quadratic formula will give you the exact answers. Okay. There'll also be, it also encompasses roots that are imaginary. So when the parabola really doesn't cross the x-axis, the quadratic formula can give you those complex roots. And then in comparison to a situation where those things are prime, right? Or you're going to end up with irrational roots. Irrational meaning that it's like has a square root of 7 attached to it. You're not going to be able to factor that very well. Okay. And once again, that turns into an approximation. So the quadratic formula will give you the exact answers of these roots, and it handles any quadratic equation that you can throw at. Okay. The main portion of the quadratic formula is known as the discriminant. Okay. It's the square root, or it's b squared minus 4ac. And you'll see that in this next one. So here is the quadratic formula. It says the solutions of a quadratic equation in form ax squared plus bx plus c is equal to 0, where a cannot equal to 0, are given by the following formula. That's x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and for lack of a better term, the way you use these is you plug and you play. Okay, we're going to be plugging numbers or the coefficients into its given variable, and then we'll carry out all the arithmetic to solve. Okay, so you can see on our example we had x squared plus 5x plus 6. So when we're plugging that into the quadratic formula, remember it's a negative b for opposite. So if b was a negative in the equation, b would turn out to be a positive when we were working the equation. Plus or minus the square root of b squared minus 4 times a times c. So order of operations has to play a factor into this. Okay, understand that we need to do all the exponents first, then we would do the multiplication, then we can subtract. Okay, you wouldn't want to take 25 minus 4 times 1 times 6. That's going to give you a way different answer. So we got to follow order of operations as we go through, and we'll resolve the denominator at the very end. Okay, because you have 5 or negative 5 plus or minus. Okay, so what this does, this plus or minus, here it actually breaks it into two separate. Okay, because parabolas, they have two ends. So you're going to get two different answers for roots. And that'll be true unless your discriminant, which is underneath the radical here, is equal to 0. So this b squared minus 4ac, that's what's known as the discriminant. And what that tells you is if it's equal to 0, we're going to have one rational root. Okay, meaning that the vertex of the parabola is on the x-intercept. If it's a positive number, okay, it means we're going to have, it's a positive number that's not a perfect square. It means that we're going to have two irrational roots. If it's a positive number that is a perfect square, we have two rational roots. And then if it's a negative number, is in those situations where it's no solution, and that's where we get our complex roots, using the square root of a negative number. So I comes into play. Other key things that you need to have when using the quadratic formula is it needs to be set ax squared plus bx plus c. Okay, it has to be set equal to 0. It doesn't work if you have the constant on the other side. So some arithmetic or some algebra to move that to the other side. So whatever we are solving is always going to be set equal to 0. All right, let's get into the first one. So we have solved x squared minus 8x, which is equal to 33. So this one, as you can see, it's not in a format where we can use the quadratic formula. We have to bring that 33 to the other side. So x squared minus 8x is equal to 33. To set it equal to 0, we'd subtract 33 on both sides. And the new equation that we're working with is x squared minus 8x minus 33 set equal to 0. Okay, and then like I said, it turns into plug and play. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2. We have that general formula, and we want to plug these coefficients in. You remember whatever is associated with your quadratic term, that is the value for a. Whatever is associated with the linear term, just the single x, that is the value for b. Whatever is associated as the constant, that is c. Okay, if you had a situation where it was x squared minus 8x plus 0, then you'd plug 0 in for c. Okay, if you don't have a linear term, or if it's just x squared minus 33, then you would plug a 0 in for b. Okay, even though they're still placeholders, you still have to plug those in. So our equation that we're going to be working is x is equal to negative 8 to show the opposite, plus or minus negative 8 squared minus 4 times 1 times negative 33. All over 2 times 1. Okay, so to rework it, to make it a little simpler, we're going to take care of the exponents. We'll do the multiplication all together, and then we'll rewrite it. So x is equal to 8, because it's a negative, plus or minus negative 8 squared is 64, minus 4 times 1 is 4, times a negative 33, I think, is 132. All over 2. Double check that to make sure that 4 times 33 is 132. Yes, I was right. Okay, 64 minus 132 is negative 68. So now that we've taken care of the exponents and taken care of the multiplication, then we can do our subtraction. So it's still x is equal to 8 plus or minus the square root of 68 or negative, nope, that's going to be 196. That's negative there. All over. Okay, now we can find the square root of 196. 196 is a perfect square. The square root of 196 is 14. So if I erase to give myself a little bit more room, I'm going to be left with that x is equal to 8 plus or minus 14 divided by 2. Okay, at this point, once you've resolved the radical, okay, it's acceptable to break it into 2 different equations, one with a plus, one with a minus. That's plus or minus, 2 ends of the parabola, so we have to split it. So our first root, x is equal to 8 plus 14 divided by 2. And we'll take care of the plus first. then x is equal to 8 minus 14 divided by 2. This side, 8 plus 14 is 22, divided by 2, x is equal to 11. Okay, so that's the first point at where the parabola crosses the x-axis. Next one, 8 minus 14 gives you negative 6, divided by 2 gives you negative 3. Okay, this is one where the discriminant was a perfect square of 196. So since it was a perfect square, we have two rational roots. Okay, we don't have the element of the radical staying. Okay, we can resolve this, and we want to go all the way down to exact answers. So if the discriminant isn't a perfect square, we're going to leave that radical in there. Okay, because one, then we don't have to round. And it's the most exact answer that we could provide. But it's x is equal to 11 and x is equal to a negative 3. All right. So write the form in the ax squared plus bx plus c. That's just them moving it to 33 to one side so that we are always set equal to 0. Okay, it does not work if it's not equal to 0. Okay, so we have our a term, our b term, and our c term. We're going to plug those in to the quadratic formula. So negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times a negative 33, all divided by 2 times 1. See, it's 8. 64 plus 132 gives you 196. Okay, and like I said, 196 is a perfect square. The square root of 196 is 14. So 8 plus or minus 14 divided by 2. We separate them as soon as we resolve the radical. We can separate them from there. We get that x is equal to 11 and x is equal to a negative 3. Okay, and like I said, this works for each and every quadratic equation. Sorry, I have a student email me. There are our final answers. Okay, so here we have x squared plus 13x is equal to 30. First step, once again, we have to get it into where it is set equal to 0, and then we can plug it in. So in this case, we're going to subtract that 30 from one side, from the right side, and bring it to the left. 13x minus 30 set equal to 0. Okay, once we get it into that form, then we can enter into the quadratic formula. So for this one, x is equal to negative 13, okay, plus or minus square root of 13 squared minus 4 times 1 times negative 30, all divided by 2 times 1. And we can simplify. So the negative 13 will stay because it was positive in the original equation. So x is equal to a negative 13 plus or minus the square root of 169, which is 13 squared, minus 4 times negative 30 minus a negative 120. Yes. So that'll turn out to be a plus, all divided by 2. Carry it, take care of our subtraction in the middle or underneath the radical. So x is equal to a negative 13 plus or minus the square root of 289 over 2. The square root of 289 is 17. So I'm gonna use 17 and split it. So x is equal to a negative 13 plus 17 divided by 2. And x is equal to a negative 13 minus 17 divided by 2. On this side, negative 13 plus 17 is 4. 4 divided by 2 is 2. This side, negative 13 minus 17 gives you a negative 30 divided by 2. X is equal to a negative 15. So your two roots are x is equal to 2 and x is equal to a negative 15, which should correspond to B. All right, so one rational root. We're going to solve x squared minus 34x plus 289. See, with some of these numbers, a calculator is going to be handy. If you're not using a scientific calculator, you can always use like your iPhone and put it to the 1/2 power. That'll take the square root. If you get a whole number, that means it's rational, or it's a perfect square. If you get any sort of decimal, then you got to kind of break it down like we did previously. So x squared minus 34x plus 289. That's equal to 0. And we will run it through the quadratic equation. So x is equal to a negative 34 plus or minus the square root negative 34 squared minus 4 times 1 times 289 all divided by 2 times 1. Okay, just plugging it into the quadratic formula. Okay, and then we want to simplify. So x is equal to 34 plus or minus the square root of 34 squared. It's like 1,156 minus 1,156. Okay, because 4 times 289 is 1,156. All divided by 2. Okay, so you can see here, I know this is going to turn out to be a 0. So whenever this underneath the radical turns into a 0, it means that your vertex is on the x-axis. We're only going to have one real solution in this one. Okay, and that's because x is equal to 34 plus or minus 0, all divided by 2. Okay, 34 plus 0 divided by 2 is 17. 34 minus 0 divided by 2 is 17. So our one root in this case is x is equal to 17. And like I said, the hardest part of this is remembering the formula that x is equal to the opposite of b plus or minus the square root b squared minus 4ac all over 2a. And then just being patient enough to remember that you can't resolve this subtraction until you take care of the exponent and the multiplication. Okay, like I said, those are the two most common mistakes on a problem like this one. But x will be equal to 17. So we have our quadratic formula. So a negative 34 Negative 34 squared is 1,156. 4 times 289 is 1,156. That's what gives us our 0 there. And since our discriminant is 0, we know that we're only going to have one root. That's because 34 plus 0 and 34 minus 0 are the same answer. So the solution to this one will be 17. The hardest ones are probably the ones where you get irrational roots, where you actually have to split them. All right, one more. So x squared minus 22x plus 21. This one I have a feeling is going to be, I don't know, if I take a guess, I'm going to say 22. X squared minus 22x plus 121. Set equal to 0. Identify A, B, and C. Plug it into the quadratic formula. So a negative 22 plus or minus the square root negative 22 squared minus 4 times 1 times 121 all over 2 times 1. 22 squared is 484. So x is equal to 22 plus or minus the square root of 484. 4 times 1 times 121 is 484. So you can see that's going to equal out to 0 all over 2. Okay, so that's x is equal to 22 plus or minus 0 divided by 2. 22 plus 0 divided by 2 is 11. 22 minus 0 divided by 2 is also 11. So the answer in this case is going to be letter A, or 11. All right, here we get into the complex ones, irrational roots. Okay, these are irrational roots are happening when we can't get rid of the square root sign. Square root sign stays. But we reduce it down as far as we can. We split squares using the product property of rationals. Very similar to what we did when we were talking about complex numbers. Plus 2 set equal to 0. Okay, we don't have to do any algebra to get it set equal to 0. It's already there. So all we have to do is plug it into the quadratic formula. So x is going to be equal to a negative 6 plus or minus square root of negative 6 squared minus 4 times 1 times 2. That's nice and easy. All over 2 times 1. Okay, now we want to simplify. So x is equal to 6. Negative makes it positive. Plus or minus the square root of 36 from negative 6 squared minus 8 divided by 2. Okay, so x is going to be equal to 6 plus or minus the square root of 28 divided by 2. So at this point, this is what causes it to be irrational. Okay, it's still roots. It's not complex roots. It's just irrational roots. 28 isn't a perfect square. So if you remember, the square root of 28 using the product power of radicals can be split into the square root of 4 times the square root of 7. Okay, the square root of 4 is 2, and the square root of 7 has to stay. Okay, so when I split this, I'm going to write it as x is equal to 6 plus 2 square root of 7 over 2. then x is equal to 6 minus 2 square root of 7 over 2. Okay, and at this point, you can actually say that you're done. Okay, but you actually want to simplify these. You want to split them. So 6 divided by 2 is 3. 2 square root of 7 is just, and divided by 2 is just the square root of 7. So x is equal to 3 plus the square root of 7. And x is equal to 3 minus the square root of 7. Because the 2's will cancel out, and you can split those. 6 divided by 2 gives you 3 on both of them. Very shallow problem. You see the irrational roots are probably the hardest ones because you got to split that radical apart, find perfect squares that go into it, and then resolve it. So we have the quadratic formula. We plug it back in. So 6 plus the square root plus or minus the square root of 28 equal to 2. So 6 plus 2 square root of 7 divided by 2, or x is equal to 6 minus 2 square root of 7 divided by 2. And so the exact roots are 3 plus the square root of 7 and 3 minus the square root of 7. The approximate solutions, you could put them in a decimal form, but then that requires you to round. Whenever you round, you're not as exact as you possibly could be. All right, knock this one out. So x squared minus 5x plus 3 set equal to 0 using the quadratic formula. Like you can see, it's very repetitive process. Okay, but the nice thing is it's exact and it's pretty simple and easy to work with. X squared minus 5x plus 3 set equal to 0. Quadratic formula, x is equal to the opposite. So -5, -5, or -5 plus or minus the square root, -5 squared minus 4 times 1 times 3, all over 2 times 1. So if we simplify, x is equal to 5 plus or minus the square root of 25 minus 12 over 2. Okay, and you can see 25 minus 12 is going to equal the square root of 13. 13's prime, so nothing really else goes into it. So x is equal to 5 plus or minus the square root of 13 all over 2. We can't do anything with that radical. We can't break it down any farther. So since we can't break it down any farther, this is our final answer right there. 5 plus the square root of 13 divided by 2, and 5 minus 13 square root of 2. You might say, why would we not simplify 5 divided by 2? Well, the whole goal is to stay exact. Okay, so that would bring in the decimal, and we don't want to see decimals on this one. So our answer is right there. Answer D. And that's simply because we can't do anything farther with that radical. 13's prime, so the only thing that goes into it are 13 and 1. All right. Last type of examples are when we have the complex roots. Okay, so we have x squared plus 13 is equal to 6x. So first step, we have to rework it so that we are set equal to 0. So x squared plus 13 set equal to 6x is going to turn into x squared minus 6x plus 13. because I'm going to subtract 6x from both sides. Plus 13, set it equal to 0. Okay, now I've got it in the format where I can use the quadratic equation. So x is equal to a negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 13, all divided by 2 times 1. Now I simplify. X is equal to 6 plus or minus the square root of 36 minus 52. All over 2. So 36 minus 52 is going to give us an irrational, or not irrational, imaginary number, because x is going to be a negative 16 underneath the radical. But we can solve that just with the element of 4i. So split it. X is equal to 6 plus 4i. Square root of negative 16 is 4i over 2. And x is equal to 6 minus 4i over 2. I can split those and solve. Okay, so x is equal to 3 plus 2i, and x is equal to 3 minus 2i. Because 4i divided by 2 is 2i. 6 divided by 2 is 3. 6 divided by 2 is 3. Negative 4i divided by 2 is 2i. So you can see it's the same process, just using different roots. These are what's known as complex roots. So this equation or parabola would never touch the x-axis. It only has complex roots. So we plug it in. 6 plus or minus the square root of a negative 16 divided by 2. So 6 plus or minus 4i. So the answer, x is equal to 3 plus 2i, and x is equal to 3 minus 2i. Okay, you split them and solve them that way. Simplify them all the way down. We don't have to do that. All right. I believe this is the last one, if I'm not mistaken. Or it might be one more after that. But pretty short because it's pretty simple. Like I said, it's a lot of plug and play. Hardest part is just remembering the formula. All right, so we get x squared minus 4x plus 5, set it equal to 0. Okay, because I had to subtract 4x from both sides. Plug it into my quadratic equation, quadratic formula, negative 4 plus or minus square root negative 4 squared plus 4 times 1 times 5 all over 2 times 1. Simplify. X is equal to 4 plus or minus the square root of 16 minus 20 all over 2. 16 minus 20 gives me a negative 4. So x is equal to 4 plus minus the square root of negative 4 divided by 2. The square root of negative 4 is 2i. So x is equal to 2 plus or minus I. When it's all said and done. because the square root of -4 is going to give you 2i. 4 divided by 2 is where that 2 comes. 2i divided by 2 is just I. All right, here is basically everything wrapped up and summarized. So you can see here, when b squared minus 4ac, or the discriminant, is greater than 0 and it's a perfect square, you're going to have two real rational roots. Okay, those are like your whole numbers or decimals that come to a complete stop, or they repeat. There's some kind of pattern there. Okay, if b squared minus 4ac is a positive number, but not a perfect square, then you have two real irrational roots. That's where the square root sign stays with you. Okay, you can't get rid of it, like the square root of 13 or the square root of 28. Okay, if b squared minus 4ac is equal to 0, you're going to get one real rational root where the vertex is on the x-axis. Okay, and then anytime that b squared minus 4ac is a negative number, you end up with two complex roots. Those are the imaginary numbers where there is an element of I. Okay, so I'll give you just a couple seconds to write that stuff down. And then we're going to use the discriminant just a little bit to figure out what type of roots we have. We won't have to go all the way through the quadratic though. What concept summary? Oh, those are just options. Those are just the options of how you'd solve them. Like how they say graphing and then factoring and then complete the square, the quadratic formula, that stuff.
I didn't know if you were writing it down though, so.
Oh, not necessarily. Because we all know the ways that we can solve them. But yeah, I'm just going to go through those last couple problems and be good. Alrighty, let's use the discriminant. So find the value of the discriminant for x squared plus 3x plus 5, then describe the number of type and roots, the number and type of roots of the equation. So remember, the discriminant is equal to b squared minus 4ac. So we just plug those in. So in this case, it's going to be 3 squared minus 4 times 1 times 5. And I just pulled those straight from our equation. 3 squared is 9. 4 times 1 times 5 is 20. That equals a negative 11. Okay, so this means that we have two complex roots. Okay, they're imaginary. They don't really touch the x-axis at all. We found that from the value of our discriminant. Two complex roots. All right, another one. Find the value of the discriminant. So once again, it's b squared minus 4ac. Nick, don't play on your phone, please. So that's negative 11 squared in this case. Minus 4 times 1 times 10. Negative 11 squared is 121. minus 4 times 1, which is 4 times 10 is 40. So that's equal to 81. 81 is a perfect square, where the square root would be 9. So this has one real root. It's a positive number that's a perfect square. So 9 is the square root of 81. Makes it nice and easy. So they're two rational roots, meaning that they're going to be whole numbers or have a decimal that is repeating. And the final one, we have x squared plus 8x plus 16. We find the discriminant. That is 8 squared minus 4 times 1 times 16. Okay, 8 squared is 64. Minus 4 times 1 is 4 times 16 is 64. So that sets up equal to 0. So the value of the discriminant is 0, means we have one rational root. The vertex is on the x-axis in this case. And that is the lecture. That is the quadratic formula. Like I said, it's a little bit easier than factoring.